So thank you so much to Julia and Rob for organizing this. I'm really excited that CDAC is getting started. So I'm one of the data science faculty members at the Harris School across the Midway. We have a growing set of students interested in data science and professors doing data science-y related things. Having said that, I'm actually by training an economist, and so I was particularly excited when Julia asked me to give this talk because I've given this talk 30 times to economists, and so that means I've heard most of the questions that economists will usually ask, and I've given this talk 0 times to computer scientists, and that means that I've heard 0% of the questions that a computer scientist will typically ask, and so I'm happy to take questions at the end, but I'm also happy to take questions as we go through the talk, and it's really hard for me to know what are the things that are obvious where I should speed up and what are the things that are confusing where I should slow down. So the more feedback and questions that you're able to ask as I go, the better it'll be for hopefully being clear. So this is a paper which Julia actually mentioned briefly in the bio, trying to understand what happens to spending during unemployment. And the way that we do this is we study spending for people who have bank accounts with Chase Bank and get direct deposit of their unemployment insurance benefits into their bank account. And the sort of key lesson that emerges from our empirical analysis is that spending drops exactly at the times that income drops. So there's going to be a drop in spending at the start of unemployment and then a second drop in spending exactly when UI benefits run out. And this result has positive and normative implications. So by positive here, I mean for thinking about standard models. By standard here, I mean standard sort of economic models. And then by normative, what I mean is thinking about how do we design public policy around unemployment. So on the positive side, what happens to spending during unemployment can be used excuse me, can be used as a way to test between different theories in economics about how people set their spending. So what I'll show you is that the way people spend money during unemployment is inconsistent with a rational model where people are liquidity-constrained and forward-looking. And then it is consistent with a behavioral model where some people are myopic in their spending decisions. And I'll be precise about what I mean by myopic a little bit later in the talk. On the normative side, we find that the gains from making UI benefits longer than their current length, which is 6 months in most states in the US, are substantially larger than the gains from raising the level of UI benefits for the time when people are already receiving UI benefits. And that then has some policy implications that I'll talk about in some more length. So I can summarize the talk in words, but I can also summarize the talk in a picture. And so I'm going to use one picture to summarize essentially all of the lessons of our paper. So on the x-axis, I've plotted months since first UI check. And so there's a household who her spending is approximately constant. Her spending drops discretely when unemployment benefits first begin, or when unemployment begins. And then every additional month of unemployment is bad news. And so spending is going to drop a little bit because one more month of unemployment is a little bit of bad news. Now, this is what you get from sort of the standard rational model with people who are forward-looking. I've drawn a vertical line here at the month where UI benefits exhaust, but you can see that from the perspective of these models, or this class of models, there's nothing special about the month in which UI benefits exhaust. Because 1 month before UI benefits ran out, you knew with 80% chance that you were going to get to that date. And 2 months before UI benefits ran out, you knew with a 60% chance that you were going to get to that date. And so exhaustion, I've added it to the plot, but there's nothing that the model doesn't essentially pick it up at all in any high-frequency sense. And in the data, we see something quite different. So there's a drop in spending at the start of unemployment, whose magnitude is similar to what's predicted by the buffer stock model. Then spending is dropping a little bit while receiving UI benefits, but not very much. And then at UI benefit exhaustion, there's a sharp drop in spending. This is spending on non-durable goods and services, and I'll go into some detail about what the definition is, of by sort of 13% of household non-durable spending drops exactly in the month that UI benefits run out. And so the fact that spending drops so sharply when UI benefits run out is surprising from the perspective of the standard model, which I've painted here in green. And so the sort of structure for the talk today is I'm going to spend probably 2/3 of my time telling you about how we construct this red series, understanding what happens to spending during unemployment, and showing you that spending during unemployment is very, very sensitive to income. And then the last third, I'll talk a bit about how we construct this green line from the model and some alternative models that are behavioral models that are able to do a better job of fitting the data. Did you have a question?
Yeah, I was thinking, this buffer stock model, I have no idea what it is.
Yeah.
But does it not have a feature in it that indicates when a person's income drops to zero? I mean, that seems like an important feature that a model should have. And it's
great. So because we're studying households, when UI benefits run out, the best estimate of the household's income is that it's 50% of what it was before unemployment began. So it's not zero, but it still is really bad news. And intuitively, what this model predicts, and I could have just put canonical model or rational model instead of buffer stock. It would is when I tell you something bad is going to happen in the future, you cut your spending today so that you have more money in your bank account for the potential bad risk of unemployment exhaustion.
This is some sort of agent that plans ahead, knows that's coming, and then the day it happens, you knew it was happening, and you don't actually change your...
Exactly. So I'm not saying that's how the world works. I'm saying that's how the standard model works.
Would the average economist on the street say that, yeah, probably most people don't do that, and this is about understanding?
So my best way to answer this is using a Thaler anecdote. So we showed this plot in graduate school to one of our advisors, and he was like, I don't get it. Like, of course people behave like the red line. And we said, no, like the models predict that people prepare for bad events, like UI benefit exhaustion. And then he said, oh, I learned this from Thaler. Like I had to turn on my econ brain. My econ brain was off. Of course the standard model predicts that people will prepare for UI benefit exhaustion. So I think if I'd done an alternative exercise of polling everyone in the room, which of these plots do you expect to see? I think most people would have answered red, but the models that all economists use say people prepare for bad things to happen, and that's a foundational aspect of the rational model. So basically what we're saying is that foundational aspect of the rational model is inconsistent with what we see people's actual behavior to be during spending.
Thank you.
Cool. More questions are welcome, and I promise to not pick on anyone else, but thank you for... OK. You just click through many slides all at once. OK, so I'm going to talk about the data set. I'm going to talk about the empirical results. And then I'm going to talk about positive and normative implications. And this is the part where I'll get to describing what the model is, but you intuited the assumptions exactly correctly. So I'm going to talk first about how we build this data set, who's in it, how we construct spending and employment histories, and how we go from bank accounts, which are an administrative unit, to households, which are the unit that we're actually interested in studying. Then I'm going to talk about representativeness of who's in the data set. And then I'm going to compare the spending that we see in this Chase data to external benchmarks. So we study 186,000 households who are receiving UI benefits in their Chase checking account. And this sample is on the order of 1% of all of the households that are in the Chase data. So this is not big data in the sense that we can store information about these 186,000 households in memory and do the analysis in memory without needing sort of any big data techniques. To work with the full data, those data cannot be stored in memory, and so you do need big data techniques. But for this paper, because we were just studying 200,000 households, we could just pull out that subset and work with that subset. We have data from 2013 through 2016. We're going to study everyone who receives UI after January 2014. And the reason for focusing on that cutoff date is there were a bunch of extensions of UI benefits during the Great Recession, and those had all terminated by the end of 2013. We have data from people in 20 different states. we have data from your bank account on how much you're spending and what your income is. And then if you have a credit card with Chase, we see your spending on that credit card as well. So I'm going to first talk about how we go from bank account outflows, which are a concept that we see in the data, to consumption in the sense of what are our best guess of what are households spending on things that they'll actually consume. And there's a paper that took different categories in survey data from the Consumer Expenditure Survey by Anna Maria Lusardi. And she categorized spending into one type of spending, which she called strict non-durables. So if you go to the grocery store, if you fill up your gas tank, if you get a lunch at a restaurant, that is all going to be categorized as strict non-durables. There's another category which we call other non-durables because they're not lenient non-durables, wouldn't really make much sense, which is things like clothing, payments at the doctor. These might be things that you need, but these aren't necessarily things that you need on a monthly basis, whereas groceries, utility, electricity, gas are things that you're more likely to need on a monthly basis. There's also, we see a substantial amount of cash withdrawals from the bank account. And we're going to categorize those as consumption because in other surveys where they've asked people, when you have cash, what do you spend it on? The answer is that people are basically always spending it on things that would end up in one of these bins above of being spent on non-durables. Now, this is all the spending where we can convincingly assign it a category, which is consumption. But there's also two other types of spending, which is not obviously consumption by the economist definition. So one is spending on durable goods. So if you buy stuff at Home Depot to improve your home, that's durable consumption. But the improvement you make to your home might last for 5 or 10 years rather than being something immediately for today. Debt payments are similarly a form of durables. And then there's a bunch of spending that we don't know what it was for. So if you write a paper check out of your bank account, or you do an electronic transfer, and it just says like to Julia Lane, I don't know what the payment was for, and so those are all going to be uncategorized. And so in the talk today, I'm going to focus on the subset of spending that is above the durable line. But in the research more broadly, we've also studied what happens for the categories below the horizontal line, and the results don't really differ if you add those. Any questions about spending data? OK. So on the income side, there's a subset of bank account inflows that are particularly important for us, which is we can see your paycheck. To be clear, I don't see your paycheck with your name. I see a tag that says this has been tagged as payroll. And so we can use the paychecks to construct employment histories, taking a guess on a monthly basis on what employer did you work for and how long were you employed there? Did you start a job? Did you end a job? One important caveat about our data is that we have data on bank accounts, and we're interested in studying households. And at least when giving talks to academic audiences, people will often say, well, I've accounted 2 different banks. Like, what do you do about me? And I found one Chicago Booth economist who has accounts at 5 different institutions. But fortunately, this economist who will remain unnamed is not typical. And most American households have accounts at one bank and not more than one bank. Maybe a quarter have accounts at more than one bank. And so we're going to try to find the subset of households that are using Chase as their primary bank. And the way we do that is we take people who have at least 5 payments every month coming out of their bank account. This restriction isn't important. The results are the same, essentially, if we drop the restriction. But this is our best guess at what's happening to household consumption does involve keeping this restriction. Yeah?
You're only checking spending out of checking accounts. You're not looking at credit card data?
Debit. So I said this very briefly, but if you spend on your credit card, I will categorize it as durable or non-durable using the same criteria described above.
Okay.
But I only see the categories for your Chase credit card.
Yeah.
So if you have a non-Chase credit card, I can see you paying your credit card debt or not, but I don't know what you spent it for. Yeah. OK, so a central challenge when working with sort of new, fancy, potentially selected sample administrative data is who's in the sample, why are they in the sample, can we learn any general lessons from the people in your sample or not? And so there are many different summary statistics that we go through in the paper to try to think about this, but I find this to be the sort of best way to summarize the results of that exercise. So on the x-axis, I've plotted what is the average monthly UI benefit in the 20 different states in our sample. And then in the y-axis, I've plotted what is the average UI benefit that is deposited to the bank account of a Chase customer who's in my analysis sample. And the reason why this statistic is so informative is that UI benefits in every state in the US are a function of your prior employment history. So if your prior earnings are higher, you get more in UI benefits. And so if you thought that our sample was significantly richer than typical UI recipients, then all of the states would be above this 45-degree line. If you thought our sample was significantly poorer than typical UI recipients, all of the states would be below this 45-degree line. And in fact, the states are all on the 45-degree line. And so our sample, as best as we can tell using this measure, which is the best UI-specific measure that we have, looks like UI recipients, the general pool of UI recipients. Do you have a question? Oh, no, I thought you raised your hand, but maybe I missed.
I actually do have a question, but it might just be really clear from the data. How do you know which state they're in? Because like, I might have opened my bank account where I used to live, but now I live somewhere else, but I also work remotely and I'm receiving funding from a different state.
So we are using the address that's listed on your bank account, but because we know what state is paying you UI benefits, that gives us a cross-check. And those two give very, very similar numbers. So this shows you what does spending look like on non-durables in our data compared to two external benchmarks. So one benchmark is there's a survey run by the Bureau of Labor Statistics called the Consumer Expenditure Survey, where they ask people to remember what they spent in the past month. And this survey is notorious for under-reporting spending. And you can see that our estimate of spending from the bank account data is substantially higher than the estimate from the Consumer Expenditure Survey. There's a second series, which basically adds up across all the sales of different stores in the US to estimate non-durable consumption. And we're significantly lower than that series. And the reason for that is basically these uncategorized spending that I mentioned before. We're not capturing all of your spending on non-durables, but we think we're capturing most of your spending on non-durables. OK, so with this, I'm going to get to the empirical results. So I'm going to start by just showing you a set of completely non-parametric plots about the evolution of spending. And I'm going to start by picking on Julia for a minute. So let's pretend, hypothetically, that Julia has become unemployed. And so Julia calls up the UI office and says, hey, I'm unemployed. I'm filing for UI. I'd like to get a UI check. And then 1 month later, Julia is an attractive job market candidate, immediately hired. She calls up the UI office again and says, I don't need UI benefits anymore because I found a job. And so this shows you the evolution of non-durable spending for people like Julia who receive exactly 1 month of UI benefits, which mean the household was unemployed, and then the household went back to work again. Now, or the household member. One important thing to mention is that you see spending is actually dropping a little bit before UI benefits start. And the reason is it takes a couple weeks to start getting your UI benefits after you become unemployed. And so that's why you're going to see dips that are slightly before 0 on the plot. So this is the Julias of the world who are unemployed for 1 month. This is people who are unemployed for exactly 2 months, exactly 3, exactly 4, exactly 5. And I mentioned briefly before, but it's important to emphasize, the reason that I know that all of these households were employed for exactly 1, 2, 3, 4, or 5 months is that for UI benefits in typical states, in typical economic circumstances in the US, you receive UI benefits for up to 6 months. And so that means that 6 months is special, because after 6 months, your UI benefits run out. And so all of these people went back to work between 1 and 5 months after the start of their unemployment. And then this shows you the series, when the slide decides to advance, I went too far, for people who are unemployed for at least 6 months. And what you can see is that this series looks very, very different than all the previous ones, because these households experience a loss of their UI benefits, And then the series gradually drifts up afterward as people go back to work. So there's something special about UI benefit exhaustion, where in general, there's nothing special about 6 months after the start of when you're unemployed, unless your UI benefits run out, in which case there's something very, very special that you can see here. So this plot gives you a lot of information, but it might almost give you, in some ways, too much information. And so for comparing what happens to spending in our data to different models, what we want to do is we want a way to collapse the data. And so the way we collapse the data is very simple. We take all UI recipients and trace out what happens to their spending before unemployment begins. And then we say, let's take the people who are unemployed for at least 2 months and compute the change in spending for that subgroup for the next month. And then we increment for the next month people who are, this is this evolution of spending from here to here for people who receive at least 3 months of benefits, at least 4, 5, 6. And so these are people who exhaust UI benefits and haven't found a job after their UI benefits run out. And so this is this very sharp drop in spending that I showed you on the very first slide at the start of the talk. You look afterward and you focus specifically on the people who still haven't gotten a job. Spending is continuing to drop off afterward as well. And so this gives you sort of a summary measure of what happens to spending during unemployment. There are 2 special moments. One is the start of unemployment has a big drop in spending. And then the exhaustion of UI benefits has a drop in spending that is twice as large as the start of unemployment. And we've known, I skipped this slide before for time reasons. Economists have known for a long time about this region. We've known that unemployment lowers spending, which is not that surprising. But we've never, before access to these data, been able to understand what happens exactly at UI benefit exhaustion, which is that basically going from here to here, we never had the right time data, and we didn't have the right sample size to be able to draw a picture like this before. So I'm going to now dive into some more of the details of the empirical analysis. But if you remember one picture from this talk, this is the picture to remember, because this is the picture that summarizes all of our most important findings. So I'm going to show you 3 other types of evidence beyond that basic series that consumption tracks UI benefits. And the first, I'm going to focus on what we call generous New Jersey. So New Jersey is a state which is actually very good at getting UI benefits out the door quickly on average. And so if you look at income, which is your paycheck plus your UI benefits in New Jersey, there's actually this spike in the first month, where income is actually a little bit higher in the first month of UI benefits. And the reason that arises is because there are some households who are getting their last paycheck at the same time that they're getting their first UI check. And so when I first made this plot, my co-author, Pascal Noel, who's who teaches at Booth, I said to him, oh, we should just throw out New Jersey like there's a bug going on here. And we eventually figured out, no, they're very quick at starting benefits. And actually, this is like a good way to test how do people spend at the start of unemployment. And so what you can see is that there's a spending in New Jersey is a mirror image of income in New Jersey. That when people get that week with an extra paycheck and a UI check at the start of unemployment, they spend a bit more in that month and a bit more in the 2 subsequent months. And so this is a piece of evidence that spending is responding at a essentially month-by-month frequency to different levels of income during unemployment. So generous New Jersey teaches you about the start of unemployment. On the flip side, I'm going to show you stingy Florida. So Florida is stingy in 2 ways. In Florida, during this time period, benefits last 4 months. In addition, the benefit level is much lower. And so here I've plotted income in the typical 6-month state, and then income in Florida by comparison. So there's a bigger drop at the start of unemployment, and there's a drop at month 4, which is when UI benefits run out in Florida. So that's income. Let me show you spending. So spending is, again, a mirror image of what happens to income. So in Florida, there's a much bigger spending drop at the start of unemployment. And then there's a drop in spending exactly at month 4 when the UI benefits run out. And there's nothing happening in month 6 in Florida, just like there's nothing happening in month 4 in the main sample. And so this is a second piece of evidence of just how strongly, month by month, spending is responding to income specifically to UI income coming out of UI benefits. The last type of evidence for trying to make the case that consumption is changing during UI, as opposed to just what your spending is, say, at the shopping mall, is to look at spending categories. So the spending categories that drop most at UI benefit exhaustion are spending at discount stores. So this is like Target and Walmart. Spending at grocery stores, spending at restaurants, drugstores. This is copays for doctor's visits. And then the categories that drop the least at UI benefit exhaustion are categories like payments on an auto loan, payments on a mortgage, or insurance payments. And so the way we interpret this is that when UI benefit exhaustion happens, people cut their non-durable consumption a lot. And for the most part, they continue to make payments on the things that constitute their financial commitments. And so altogether, there's sort of 3 different types of evidence beyond the main plot that consumption tracks UI benefits. The first is that income spikes up in New Jersey and spending spikes up just like income. The second is that there's a drop in spending whenever UI benefit exhaustion happens, whether it happens at 4 months or it happens at 6 months. That's exactly when spending drops. And then the third is that the categories which drop most are specifically spending on non-durables, which are the things that are likely to be consumed right away. Any questions about the data analysis before I switch to the models? OK. So I'm going to start by talking about why it's possible to use these spending data to test between different consumption models. And I'm going to talk about a buffer stock model where agents are liquidity constrained and a spender saver model with present bias. And I'll define those pieces of jargon in a minute or two. And then I'll talk about normative implications, by which I mean policy implications afterward. So there are many, many papers that show, using other types of evidence, that spending is very, very sensitive to income. And that has given rise to sort of a dual track of different theories to explain why does spending respond so much to income. So one set of theories, which I'll call rational forward-looking with liquidity constraints, or you could call it just buffer stock for short. And then the second class of theories is theories where people are behavioral, and at least some people are behaving myopically. And so these theories are the reason why this is a good setting to test between these different theories is that when there's a predictable drop in your income, the rational models say, this is bad, you know this is bad, you will prepare for it by cutting your spending in advance of the event. And so when the event itself actually happens, when the bad news arrives, you're already prepared for it, and there's no excess drop in spending exactly when that happens. Conversely, in the behavioral models, where we think these models assume people are not fully forward-looking. People are surprised that their UI benefits run out. And so then there's a excess drop in spending exactly when their UI benefits run out. So the MPC, which just means the consumption response to a predictable income decrease, is a good way to test between these models. I think I'm going to skip this slide because it's mostly about the economics literature, and so I don't think it's useful to this audience. Similarly, there's a standard way to write down that households are forward-looking and choosing their consumption and their job search decisions optimally. I'm glad to talk about this afterward if there are questions, but I actually don't think it's that useful for building intuition. The sort of best way to summarize what we're doing is we take the standard off-the-shelf model and we ask, given what we know about people's income and their liquid assets and their job search behavior, how would we predict them to spend? And that prediction is what's depicted in the red line here. This is exactly the same plot that I showed you at the start of the talk, where I showed you that the rational model predicts a sharp drop in spending at the start of unemployment, which is exactly what we see in the data. And then it predicts a gradual decline in spending in each of the subsequent months, which is quite different than what we see in the data. So the failure of this model motivated us to spend time looking at behavioral models. Skip this. And here we're going to drop the assumption that people are rational and forward-looking. And in particular, we're going to assume that they place less weight on the future than a rational agent would. And so if you assume in the data that everyone is behavioral in the specific sense of being very, very impatient, you can get them to cut their spending at the end of unemployment, but you also essentially have households that are what we would call hand-to-mouth. They just cut their spending whenever their income drops. And so if you were to assume that everyone is behavioral, you would also not do a good job of fitting the data, because as you can see, if everyone was behavioral, the spending drops would be as large as the income drops, which is much larger than the spending drops that we see in the data. And so this motivates us to use a model where we have a mix of different types. And if you basically have a mix of some types that are rational and some types that are behavioral, it's then possible to match spending behavior both at the start of unemployment and also at the exhaustion of UI benefits. I think the coolest thing that we can do to test between these two different models is to go back to Florida. So just to remind you, Florida is a state with very low UI benefits. And in addition, benefits only last 4 months. And so we asked the question, take the models that we trained on the 6-month data, so the rational model and the behavioral model, and ask them to predict what would happen in Florida if I told you that UI benefits only last 4 months and the benefit level is substantially lower than it was otherwise. And so here I have the data from Florida, which is the same Florida data that I showed you before. And then I have the predictions from the model that we trained for the rational model trained on the 6-month data and the behavioral, or the partially behavioral model trained on the 6-month data. And neither model does perfectly, but the partially behavioral model does a substantially, which is in blue triangles, does a substantially better job at capturing what's happening to spending in the data. So I think that's it for the models. I'm going to talk for 2 minutes about what are the sort of policy implications of our results. So there are lots and lots of estimates or let me try this differently with a little bit more backstory. Economists have a formula, which is called the Bailey-Chetty formula, for thinking about what is the socially optimal level of UI benefits. And the reason that UI benefits are not 0 is because we want to help people smooth their consumption during unemployment. And the reason that UI benefits are not 100, by which I mean exactly the amount of money that you earned while you were working, is that then there'd be no incentive to work at all. And so there's a lot of papers that try to quantify this trade-off. What are the consumption smoothing gains versus the moral hazard costs? And so there are lots and lots of papers which think about how should we set the level of UI benefits, what's going to be the cost of raising UI benefits, and what's going to be the gain from raising UI benefits. And so this is an active and well-developed literature. A different question you can think about is how long should UI benefits last? And if you think about all of the policy debate that happened during the Great Recession, there were no policy changes and virtually no policy discussion about this side, about what's the right level of benefits. And all of the debate was about how long should benefits last. And this is actually where we don't have as much evidence. So we have papers that ask, if we make UI benefits longer, how much will we discourage people from working? That's the loss side. But we don't have any estimates, at least prior to this paper, about what is the gain from making UI benefits longer, even though this is a really important policy topic during recessions. And so our paper fills in this cell in the bottom right of this table of what are the consumption smoothing gains from raising UI benefit, from extending UI benefits. So we first show that if you were thinking about just the level of UI benefits and what's the value of raising the level of UI benefits, our estimates are similar to this paper by Jonathan Gruber, which is, probably has like 2,000 citations, which is a lot in economics. That's sort of a very famous paper looking at consumption drops during unemployment. And then if we instead think about extending UI benefits rather than raising their level, we find that the consumption smoothing gains are about 4 times larger. And intuitively, it just comes down to the original plot that I showed you at the start of the talk. When consumption is really low, that's the state of the world where UI benefits are really valuable. And consumption's really low after UI benefits have run out. Ergo, extensions in UI benefits are more valuable than increasing the level of UI benefits. Now, there's several important critiques of this, but there's one that I'm going to address today, which has to do with, actually, I'm going to address it today in the voiceover. It's not in the slides, which is thinking about moral hazard. So it could be that when you raise UI benefit levels, people are not very discouraged from searching more, but that when you make UI benefits last longer, that has a really big discouragement effect that offsets these big gains that I'm talking about. And there's a recent literature review that goes through sort of all of the available estimates of how much moral hazard is there from extending UI benefits and raising the level. And to briefly summarize, the literature review says the moral hazard from these two different policies is pretty similar, which means that this lesson that I'm describing here about extending UI benefits being so much more valuable than raising the level continues to hold even after you account for the moral hazard. So today I've shown you a set of pictures, essentially, that spending is very, very responsive to the cash flows arising from UI benefits. And this has a positive implication, which is if you have a setting where you have a predictable income drop and you have high-frequency data on spending, you can test between a rational model of spending and a behavioral model of spending, and we find evidence that's consistent with the second theory. The spending behavior is consistent with some people being behavioral and some people being rational, but not with everyone being rational. And then thinking about the policy side in terms of normative implications, the consumption smoothing gains of extending UI are substantially larger than the gains for raising UI benefits. So I'm very glad now to continue to hear any questions you might have about any of this. Yeah, please.
So when you get the new model that can catch the consumption drop, so there seems to be, so there seems to be one or a set of parameters that matter, or is it the discount factor? I don't remember. So are these parameters the same across different states? Florida or other states?
Wait, do you mean like different states in the U.S. or different states in the states of the world in like an economic sense? So discount factor is a preference parameter. So it's like how people feel about consumption today versus in the future. And so we're doing one average value. We're doing the average that fits the average data. But it could well be that in Illinois, people are really patient, and in Michigan, people are really impatient.
Sorry, another one. So besides tracking the income and the consumption, do you also track like how much money are there already there in the account prior to employment? Maybe that will make a difference of how people like spend money.
That is a great question. Let me, I think I can give you a picture to show you the answer. See if this gets us here. Yes. Okay, so this we take the sample and we divide it into three groups by how many liquid assets do you have prior to the start of unemployment. And remember that this is going to be a coarse proxy because this is checking and savings accounts. People have liquid assets in other places. But safe to say that the income paths are relatively similar for people who have high asset or low asset, and the spending paths are quite different. So the qualitative pattern that spending drops at exhaustion is true for across these three groups, but essentially people who are low asset are the ones who cut their spending the most.
Thank you.
Yeah.
So I get how extending the UI benefits could smooth consumer spending, and that's good for maintaining their levels of satisfaction in the economy broadly, but I still wonder if that's like the right ultimate target, because the money that they're not spending is maybe being saved, and I wonder if consumers could also be served better by like if they end up spending less and just save what they're not spending.
Great. So I think that there's a bunch of interesting and important questions, which are what's the right way to design, and I'm going to say UI, like what's the right way to design, supports for job search and consumption smoothing. And there are lots of cool things we could do, and we're sort of making the point that relative to the conversation that people usually have, here's something that we should probably focus on more. But I'm not saying that this is at all the best thing that we should focus on. Yeah, so I'm like super interested in ideas around this.
And also, do you have a sense for like what kind of unemployment these people were experiencing? Because I imagine it's like a different scenario if they're like seasonally unemployed or structurally.
So some are seasonally unemployed. The typical duration is around 3 months. Some people are much longer than that. Yeah, a substantial chunk of UI recipients are seasonal unemployment, but not the majority, I think is the best quick answer.
To take a step back, can you talk a little bit about how you got access to this data and maybe some of what's good about it and what's bad about it, and what, if you have any ideas on what else you can do with it?
Sure. Well, so yes. So we went to every major bank in the U.S. and we asked them for data like this because we wanted to do a study about consumption unemployment, and they all said no. And then we had a lot of conversations, and eventually we developed a partnership. So I mentioned briefly before, but we work with JP Morgan Chase Institute, which is a think tank that was set up by JP Morgan Chase to do research using these data. So we are continuing to work with that same group. We're just starting a new project now on racial disparities in household finances. And so that's like a project I'm particularly excited about that we're going to work on next. I think these data are best for thinking about what's happening to people's lives on a day-to-day basis. So we don't have many, we have lots of surveys and data sets like tax data sets that we can track your life over 30 years where you went. But to understand someone's day-to-day financial experiences, I think that's where these data are strongest. And then their weakest, I mentioned before with the asset question, like their weakest, like we don't have a good picture of your retirement savings. I don't have a good picture of how educated you are. There's all sorts of things that I love to know for long-term inequality questions, which these data aren't good for. But for what's going on to income and spending and credit card borrowing for your day-to-day life, that's where I think these are sort of the strongest. And that's exactly what we're going to focus on in the Racial Disparities Project is how do experiences differ based on being white or black or Asian or Hispanic, which is a different category from the others, on the basis of, on a day-to-day basis in terms of income and spending. Yeah?
Do you see these trends continuing in much the same way as automation and AI continue to render certain job titles or even whole professions obsolete?
I think we're studying spending during unemployment, and there's a different question, which is how people become unemployed. But I don't think I have much to say about that from this paper.
Okay.
In this data
Oh, there's one person behind you. Sorry.
Oh, I have a question, sort of following up on the comment about seasonal unemployment. So can you kind of give us a better understanding of how you're defining seasonal unemployment? Is this like a scenario where you're saying that they're predictably unemployed at a certain period of the year, or that just by like virtue of the fact that it's only 3 months of unemployment that's characterized as seasonal?
Great. So first, I was a little not precise before about where we were getting these answers from. So there's sort of two ways that one could define seasonal unemployment. One is just UI claims spike a lot in January and also at the end of the summer as people transition out of summer jobs. And so you could use seasonality as one way. And then the other thing, yes, sort of really, is it predictable? Another thing you can do is you can look at, there's certain employers that constantly put their staff on UI when it's off, not their peak season, and so then that's another way you could define it. So I don't have those are the two typical ways that people look at it, but I don't have specific numbers for you, unfortunately. Also, seasonal unemployment rarely lasts 6 months, so that's like another way to think about it. Is like the people who make it all the way to exhaustion probably haven't been in that state of the world before. Certainly not on an annual basis, because you you wouldn't be, if you only were working 6 months a year, you wouldn't really accumulate enough earnings history to get UI for 6 months. So you had a question as well.
Yeah, on a different
Yeah.
topic though. You mentioned in passing that you saw how much the checks were, but you didn't see the people's names on the checks, which implies you had some concern for the privacy of the people who did not, I'm assuming, opt into this experiment. So how did you think about privacy, and like what was the actual granularity and type of data that you got to see?
Great. I have a pretty detailed answer for this one. So we only ever see de-identified data. There's a different team in Chase that de-identifies the data before we ever see it. We do see data at a high level of granularity, meaning for this paper, we mostly used monthly data, but in ongoing work, we see transaction level data of essentially the ins and outs of a bank account at a transaction level.
I go to CVS and then Jewel-Osco and then...
Exactly, yeah. So we see a lot of detail, and there's basically disclosure guidelines that essentially sell minima that prevent us from disclosing any individual's information in a way that might make it re-identifiable. Yeah, we feel very lucky that we basically never see PII, because it makes our life a lot easier than if we did see PII. So maybe that means that we do less of the thinking than other researchers have to do about how to handle it, but it certainly makes our lives easier not to see it. Yeah?
So for people who get out of UI before the 6 months, what is typically the trend of their income? Is it the same level as before? Is it higher or lower?
Great question. I don't think I have a picture about this in the deck. The average UI recipient, if you look at her earnings 3 years later, she's back to where she was before in terms of her inflation-adjusted earnings. Now, there's two important caveats to that. One is just there are some people who get all the way to UI benefit exhaustion probably have a long-term earnings loss of maybe 20% at their next job. Now, it doesn't tell you about the rest of their life, but their next job, they'll be paid 20% less. The other caveat is that we don't know the counterfactual. So someone who's unemployed, their earnings dip, then it comes back to where it was before. But what if they'd never been unemployed? Like, presumably they would have had some earnings growth, right? So it's hard to, without randomly assigning people to layoff, it's hard to answer that question. And fully, but I can give a partial answer. Yeah?
Well, right there it says that there's the benefits of extending UI is much greater than raising the UI benefits.
Yeah.
So, and you got a ratio for that, right, from all your models and whatever.
Yeah.
And like, where do you see that ending? Or like, what do you, like when you go to the extremes, where does this pattern end? Or what do you think it ends?
Great. So that's a great question. We haven't looked into it, not because it's not a good question, but because we wanted to make the point we should focus more on this margin, and we have an estimate for this margin. But basically, I have never done any computation that gives you a good answer to that, not because it has to end somewhere, but I just don't know where. Yeah.
Do you think this would change in different countries that have more savings, for example? Like, is your graph where it showed, people at different asset levels, and obviously people who have greater assets are not as affected. Do you think, like, in a country that I forget what the U.S. is, but it's like people have an average of like $400 in savings or something like that. So they're highly sensitive to these changes.
There's two different types of answers, and we should probably make this. Is it okay if we make this the last question? Just want to make sure to wrap up on time. So one answer is that, and I didn't have time to get to this in the talk, but it's like an important point. Even if you had $0 in your bank account, because you have a bank account and you're receiving UI, you could save for UI benefit exhaustion. So the fact that there's a spending drop at UI benefit exhaustion, like the reason this is a good test between rational and behavioral models, is even if you have $0, the rational model says that you save some of your UI benefits to prepare for exhaustion. And so the fact holds essentially regardless of whether or not you have savings at like or the test holds, not you have savings. Separately, I have, there's been something sort of an interesting development in the last few months, which is, I guess, good news for me as a researcher, but bad news for the world, which is that basically someone in Brazil has replicated our study, or at least the main aspects of our study. And so they've documented that there's a consumption drop in Brazil, in Sao Paulo, in the relatively developed part of the economy where they can track this, whose magnitude is similar to the drop that we see in the US. And so it seems to be a phenomenon that extends beyond the US based on the Brazil data, but like, I hope, hopefully we'll get a lot more evidence as more of these data sets become available in other countries.
Thank you, Peter.
Thank you.